Hello, this is the first part of the Zimba 3000 project. If you don't know what that is, that's my FPGA video game console I've been working on, and I released some information on Atari Age about it, so I'll post a link down below to the thread about it. If you want to read about it, I'll probably post the updates there, and if anybody has questions or anything, you can talk about it on there and I'll respond. So anyway, let's get right to it. In the beginning, in 2004, I designed this board here. This was my very first FPGA video game board. And this has a Cyclone 1 EP1C12. That's a 12,000 logic element part. There's an SD RAM here, power supplies, oscillator, video DAC, some level translation, a PIC, SD card, audio amplifier, audio DAC, some interface logic, and two DB9 ports here, and an expansion port here, and then on the back we got right audio, left audio, video, S-video, DB15 for RGB, PS2 mouse, keyboard port, a USB, and a power, and programming there. And what this was designed for, this was, my very first board. It's pretty old school now, but in 2004 I thought it was pretty hot stuff. But these DB9 ports were designed to take a 2600 controller, Sega Master System, Genesis, Intellivision, and Coleco, and paddles, and driving controller. And there's logic and stuff on here that the PIC would read, and then the PIC would send the data back to the FPGA and all that. And yeah, it was okay, but everything's USB today, so that's where I'm headed. So this was the first one, and I developed the FPGA NES and 2600 on this board. After the first board in 2009, I think it was, I designed this second iteration. This has two USB host ports for two controllers, a micro SD card in this case, little 7-segment display, a Vinculum 2 CPU, which turned out to be the Stinkulum, some buttons and some power supplies, a synchronous SRAM, another SD RAM, Cyclone 3 EP3C25, so this is 25,000 logic elements, another video DAC, and this one has a DVI paneled bus driver, and then audio DAC, power supplies, all the usual stuff. Then on the back, we got a DVI connector that has the RGB video and DVI signals, right and left audio. The expansion connector, which is a 13-pin DIN and 12-volt power. And that 13-pin DIN is kind of a neat little connector. So what I did with that, I did a couple things with it. I made an adapter to hook up to my Gameboy I made on some perf board. I can show that in a minute if you'll see that. And then, so to program this, I have this board I made right here. This plugs in right there, like that. And what this has on it, this has FT232 on it, which gives me USB to serial, and that serial connects to here, and that's how I was debugging it. There's a Vinculum 2 programmer, and that's pretty much about it on there. And then to use the controllers, I have this. This is a 13-pin DIN that plugs into that expansion connector, and I have two Super Nintendo controllers plugged in. And this is how I've been playing most of the games, is with the Super Nintendo joysticks, because I like those, or gamepads. I also have an NES version of this, so I can use a light gun on there. That works fine. If you have a 15 kilohertz CRT, the light gun works great with this. Obviously, it doesn't work so hot through DVI. I did get the light gun to work through the RGB. I had to modify it so it would pick up the 31 kilohertz, but it did work. Obviously, the light gun doesn't work on a flat panel display. I tried and I got nothing. Since I'm serious about accuracy, I wanted to add that Arkadia 2001 onto this system. I was having a hard time finding one on eBay for a price I wanted to pay, so I built this. This is an Arkadia 2001. Actually, it's like this. This has the 12-key keypad, the directionals, up, down, left, right, for both players. It has a start and select, or whatever the buttons are in the system. There's a CPU, video chip, flash ROM with all the games built in, and you select which game you want to run with these dip switches. And then I got headers all over the place, so I can plug the logic analyzer in, and that is how I reverse engineered this system. There's the bottom, not a lot going on. There's the AV connectors right there. So I built the entire system up from scratch. It only took me probably about 7 or 8 hours to build this. I just went by the schematic and put it together. And then, speaking of systems that were hard to obtain for a reasonable price, I made this monstrosity here. Actually, I gotta pull the camera out since it's so big. So what this is a video brain, and here's the keyboard made up of little buttons, space here. Can't remember what that did. And then here's the 2 ASICs that I found at a surplus store. So I bought 10 sets of these things, and most of them worked. And so this has all the games on it. And this is one of the BIOS ROMs, and here's the other one. One's a character ROM, one's a BIOS. I can't remember which is which. Pretty sure this is a BIOS. So I bought the weird Fairchild F8 CPU, which is here. And then, actually, that's the F8 CPU there. That's that weird interface chip for it, the 3853. That converts their weird bus into a more standard Intel type bus. Row of headers, more headers, and some other things. And what this lets me do, this let me totally debug the video brain, and I reverse engineered it again with the logic analyzer, and then the 2 boards plug together. So this is the main video and audio section, and then this is simply the CPU section that drives it. So I made a replacement CPU board with a PIC on it, and that let me poke the video a lot better and a lot faster. And here's that board. So here's the little PIC board I made, so that plugs in like this. And then this PIC hooks up to a serial port and a programmer, and then I can just debug the way the video brain worked just directly without having to run anything on the F8 CPU. So that saved me. I didn't have to program EEPROMs or anything. I just set this command through the serial port, and I was good to go. You want to see what the bottom looks like? There's the bottom. Not a lot really to it. I got these rubber feet so it would sit and not scratch the desk up. So basically I took the schematic for the video brain again and built it, and then it didn't work. And come to find out, the schematic was defective. So I found about 4 bugs in the schematic and fixed those, and guess what? Then it worked, and I implemented Video Brain. So then after Video Brain, I started working on Gameboy. And here's my prototype Game Boy I made. This has a Game Boy screen and buttons. There's nothing under there. It's just the cable comes out and connects to some wires. And then I got the Game Boy CPU on a little carrier here. This comes off. And then the 2 RAM chips, and then a ROM, and then the cartridge mapper, power supply audio, and there's a little power switch there. I'll fire this up and actually show this off. So the game fits in this EEPROM. And right now I think I have the debug code I wrote is sitting in there. Reset button there. Yep, it's working. I just gotta adjust the contrast because it's kind of hard to see. Ah, there we go. This is my test code. The test code. Yeah, there we go. Now you can see it a little better. The test code interfaced through the. I had a plug-in connector on here. So the Game Boy here interfaces to my FPGA board through this DIN 13, and that let me totally debug the video on this thing, which is extremely tricky. It took me 2 or 3 tries to actually get this to actually finish it. The Verilog, I dumped the code. I wrote most of the code for the Game Boy video, and then I just had to throw it away. And I did that, I think, 2 or 3 times just because I kept finding more weird things that were going on so I had to keep doing it. There's a reset button. That works. So audio comes out there, obviously. So yeah, this was working pretty good, and this is how I did Game Boy. So I got a Game Boy adapter or tester, the Video Brain system, and the Arkadia 2001, and all the other systems in television 2600 and 7800 actually added these little headers to all the chips, so I didn't actually have to build these, because I mainly built most of these because, like I said, I couldn't afford them. You know, the Video Brain was like $350 on eBay, so I built this faux Video Brain, and I think I paid probably $20. I had to buy these two chips, and I had to buy these weird RAM chips, but other than that, I have all these other chips I had in stock, so they didn't cost me anything, and these circuit boards are really cheap. These are like $5 each, so I'm all in for $30 on this Proto, and this was free. I had all this stuff. This one I had to pay, I think, $5 for the CPU from some pinball repair place, of all places. And then this I got off of eBay, and the little video timing generator I got off of eBay. And all the rest, I had all this stuff in stock. I got the buttons at the surplus place. Same with these buttons. And the little switches, that's from surplus place too. And all of that leads to this, the Zimba 3000 prototype. This is my third iteration of the FPGA video game hardware. This was designed to fit into some kind of custom cut acrylic enclosure I was going to make on the laser cutter we have at work. And the way this works, this was the video board here, so I have 15 kilohertz or 31 kilohertz RGB out this DB15, RGB 15 kilohertz 31 or component, S-video, composite, and then left and right audio. Yeah, these are soldered, but it's not a cardboard circuit board. It's actually a real circuit board. Uses a PCI Express edge mount connector because these are really nice and really cheap. And that just plugs into the main board like that. And then your analog features are all right in line on the back panel with the HDMI, Ethernet, and power. And the idea here was I would sell it without this analog board, and then if you wanted analog outputs, you could buy this and plug it in, and that way the people that just wanted HDMI only weren't going to subsidize those that want the analog. So I thought that would, make it cheaper for those that don't want the analog, and if you want the analog, well, you just pay for what it costs. So this analog board here, it's a 4-layer circuit board, and it's got two 3-channel RGB DACs on it, some power, audio DAC, and a few other little things. It's got EMI, RFI, ESD protection diodes everywhere, so it shouldn't be blow-upable very easily by just plugging cables in. And then the main board itself here, so like I said, I had the HDMI, the Ethernet, and the power. 2 FPGAs, these are Cyclone 5s. This is a 25K logic element and a 50K logic or 49K logic element. SD card, dual USB host, power button, some mode buttons, RGB LED for status and stuff, and another button. I think that's the power button here, and I think that was reset. USB B type for development, little USB to serial doodad, and you get 2 DDR1 RAMs for the scalar FPGA, which is Itchy, and Scratchy is the main emulation CPU, or FPGA, sorry, with 4 DDR1 memories, so that's got enough buses and enough bytes to do, theoretically, Neo Geo level games here. So I really wanted this board to run Neo Geo because Neo Geo is cool, and it's just obnoxious. There's hardware requirements. And then there's a battery, there's a real-time clock on here, and then there's another chip which is a PIC32, and that's actually Poochie, so you have Itchy, Scratchy, and Poochie. And then I have the panel bus driver here, the config ROM, and just some clock generators and power supply. And that's pretty much it. And then on the back side, there's not really a whole lot. It's just decoupling caps and other fun things like that, some few resistors. I may try to put all the parts on the top side of the board, I don't know. So, anyways, this is the old Proto. I'm not going to use this now, but This is a 6-layer board, and I had a lot of fun making it. And I may still stuff partially for testing purposes, and I'm not sure yet. But anyways, that's what I've got right now, and I'm going to use this as a base to make the Zimba 3000. So this was the original plan, but I'll probably drop the Ethernet, because, I mean, Ethernet, who really needs it for this? It'll be HDMI only. But what it will have a similar plug-in structure to this. However, the plug-in board is only going to be really small. It may only be about this wide, and I'll use a smaller connector. And what that'll allow me to do is have just a composite / S-video plug-in, an RGB / component plug-in, or an HDMI plug-in. And then the connector will be on the main board instead of on the adapter like it is here. It's on the adapter because this card edge doesn't really cost anything, but this connector does. So if I put the connector on the main board, that means everybody's going to subsidize that connector. So by putting the connector on the analog board, that not everybody was going to use, that saved some money. Then over here on the right, there's another PCIe connector here, and this was for the expansion. What this was going to be for was the cartridge expander. So if you want to play like real NES carts, the expander would plug in here. And also I was thinking of having controller ports for like real controllers and things like that. If you didn't want to use the HDMI input, if you didn't want to use the USB inputs for that. So that's what I got right now. And this would be a little bit expensive to make, so I'm going to cut this down. I'm going to get rid of this FPGA, and I'll probably go with a Max 10. And I drew up on the whiteboard here a block diagram of what the Zimba 3000 is probably going to be when I design the next board. So here we'll take a look at that. And here's the Zimba 3000 block diagram. So here's the heart of the system, the Cyclone 5, which has 49,000K logic elements. It's got the expansion connection for card adapters or controller adapters or whatever. 4 RAM chips, which are DDR1 probably. And this gives me a lot of bandwidth, which is important. The amount of RAM the system has isn't as important as the amount of bandwidth it has, because like the Neo Geo has no less than 5 separate buses with ROMs on them. So getting that bandwidth is really tough if you have more than 1 RAM, or if you have less RAM chips than say 4. And then this connects up to a Max 10, which is a fairly cheap little FPGA, and this will do the scaling, SD card, and this will have some RAM on it for frame buffers and or other data. That'll be a 2K or a 4K part. I'll probably put a 4K part on the Proto, and for production I may drop it to a 2K if I can. And then the AV module will connect through the PCIe connector, and that'll be one of HDMI, which will be the default RGB / component plus audio, or composite / S-video plus audio. And also I can make other things. I was thinking of making a vector driver. So if you want to drive a vector monitor with this, RGB XY, that will be possible also. There's a PIC32 to handle 4 USB ports, which will be on a hub. And the SD card will connect to the FPGA itself, and the PIC32 will actually operate it. And the reason for that is because this way I can vastly speed up the loading. If I'm going to do Neo Geo games, I want that SD card to basically be running as fast as possible, because some of those games get really large. And when it's fast, it also is nice because the games just load up instantly. And when you're loading a new bit stream into this to say change from an NES to a Super Nintendo or whatever, then streaming that data just really fast in that FPGA is highly desirable, obviously. That's pretty much the block diagram. I don't think very much is going to change. The only thing that's really not shown is the power supplies obviously aren't shown. Some people were asking if I could do a JAMA version of this, and theoretically I could do it through this this PCIe AV module interface. I could just make a board that plugs in there and outputs the RGB to the monitor and just accept inputs also. I was thinking about that. That wouldn't be too difficult. And then each one of these modules, obviously, when you plug it in, it will identify what it is, and this will be screwed into the back of the unit with, say, thumb screws or something, so you can just, it's user, swappable. So it would come with the HDMI, and then if you want one of these other ones, they're extra, or maybe you can substitute it, so if you don't want HDMI and you want RGB, it's possible that I may just have it at the same price or whatever. So as for cost on this, I'm not sure what this is going to cost. I don't want to say at this point how much I think it's going to cost, because I really don't know. I'm going to design the circuit board and then price out the chips and things like that and try to cut the cost down as low as I can, obviously. I'm not going to add superfluous things, like that's why there's not going to be any Ethernet. And that's why the AV modules are separate and why I don't have all of these outputs at once. It's just because it's just way too expensive. Those RGB DACs cost probably $6 or $7 each, and I need 2 of them. And then all the other stuff, like the audio DAC also. So by doing it this way, this saves a lot of money on this end of things. And this expansion port saves money too, because I don't have any of that adapter stuff built onto the board. It all just plugs in, so the people that want it can buy it, and the people that don't want it don't have to spend money on something they're not going to use. So this is the main outline for the Zimba 3000 as it stands. Pretty soon I'll probably start laying a board out. If I get bored and don't have anything else I have to do, I'll start laying the board out for this, and I'll start probably doing update videos. If I do a board layout, I'll probably do a time lapse of that so you can see how I go about routing it, kind of. But it may just be interesting to watch that, I don't know. And I'll go through the things I've done to change. Say if some of the stuff changed, I'll do another drawing on the whiteboard here to show what changed. I don't know, I'm just gonna play it by ear and see how it goes and see if this is viable or not. It may be too expensive, I don't know, but I think the way I got it designed now, I don't think it's gonna be too expensive. Hopefully I'll be able to sell this thing for a price that people are gonna wanna pay. And I don't know how many of these I'll sell. Should I do a Kickstarter or not? I don't even know. But I'm not going to worry about any of that stuff until this hardware is done and actually running games. I don't want to get into the retro VGS situation where they promise the world, and one day before the Kickstarter they don't even know what the hardware is going to do. So I don't want that to happen. I don't want a repeat of that. I just want to show exactly what I'm doing and be really quote-unquote transparent about it. Well, that was a quick little overview of the Zimba 3000 project. I hope you enjoyed it. So now you know where I'm going with it, or hopefully going with it, and what I want to do, and where I came from, and all my other little prototypes and things. So I hope you enjoyed it. Thanks for watching.